14.2, transformations of trig graphs, part 3, last part. We're just going to do some examples. So first we're going to we're going to do two examples and an application. So first, and this is when a couple of transformations happen at the same time. So y equals 3 sine of x minus pi over 2. Okay, we want to graph that because real applications have more than one transformation at a time, which you'll see in a second. So what we're going to do before we even start this is we're going to write down all the information about this equation that we know. So what is anything that makes it different? We all know how to graph y equals sine x, but what makes it different? Well, that number. So what does that number mean? It affects y, and it's called it affects the amplitude. So the amplitude equals 3, right? Absolute value of that is 3. Good. The other thing that makes this different than y equals sine x is this minus pi over 2. What does that do? Good. It shifts it to the left, pi over 2. So when we, so we're going to set up our axes, and we're going to leave a little more space to the left because we know we're shifting it to the left. Our highest point then is, instead of 1, our highest point is all the way up at 3, and our lowest point is all the way down at negative 3. And since we are shifting to, it is not to the left pi over 2, it's to the, it looks like left because it says x minus pi over 2, right? But it's always the opposite. So it's just to the right pi over 2. Because c is positive. The standard formula is y equals a sine x minus c plus d. So c is actually positive pi over 2, so it goes to the right. Shifts to the right pi over 2. So we start here at pi over 2. And then what will be the end, for one complete period, what will be the ending point? If we start at pi over 2, what do we have to add to pi over 2? 2 pi. The period of sine, unless there's some value of b that changes it, is always 2 pi. So if you add 2 to a half, you get 2 and a half. 2 and a half is 5 halves. So you go out to 5 halves, and that will be one complete period. And then I'm going to have you label one more spot in between by taking the average of these two. Anytime you want to find the middle of two numbers, you take the average. So 1 half plus 5 halves is 6 halves, which is 3. Half of 3 is 3 over 2. And then of course we cut that in half and cut that in half. So we are ready to do the graph. It's sine, so we do start at the middle or the highest? Middle. So we go middle, and then do we go up or down? We go up. If there were if this were negative 3 in front, then we would go down, right? But since a is positive, we go up, highest. So middle, high, middle, low, middle. And there's one period. And put an arrow to show that you keep going. Now it's very odd to leave a hole between, to not extend it so that it crosses the y-axis. So let's do something that'll be nice review to figure out where does it cross the y-axis. What's that called, the point where it crosses the y-axis? It's called the y-intercept. So let's go ahead, and how do you know, this is review for your final exam for any equation or function. To find the y-intercept, what do you do always? Yes, let x equal 0. Because on the y-axis, the x coordinate is always 0. So we're gonna figure out where this intercept is so we can make a nice graph. So let's just plug in 0 in here, and this will be great review too, and see what we get for y. Just replace x with 0 and see what we get for y. So you get y equals 3 sine of 0 minus pi over 2. This whole right side, we can just evaluate this right here. It's not that bad. So you get 3 times the sine of negative pi over 2. Right? 0 minus pi over 2 is negative pi over 2. So think you can do this in your head. You don't even need your calculator. Go to rotate to negative pi over 2 radians, right? That's rotating down here. What's the y coordinate there? The y coordinate is, well, what are the coordinates? Good, 0, negative 1. So the sine of negative pi over 2 is negative 1. And what's negative 1 times 3? Yeah. So negative 3 is the y-intercept. So now I can just make my graph nicer by, I know that it crosses here at negative 3. So I can just extend this, so that, and besides, the y-intercept contains important information. That's usually like what's happening at time 0 when x is 0. So you want to be able to know what the y-intercept is. Okay, we're going to do one more complete example here of graphing. Let's try, and let's actually use real function notation now. Let's say f of x equals the sine of x plus pi minus 1. Okay? So your assignment today will be doing, practicing different graphs where we change different things. So what makes this different from the graph of sine x? What's happening? What does this do? Plus pi? Left. So c is negative pi, so shift to the left pi. So, and what does that do? Minus 1 on the end? It changes the center, and where does it move it? Down 1, exactly. So shift down 1. And that's an easy one because you evaluate this and you do 1 less, so of course it moves it down 1. You're subtracting 1 from y. So, okay, so now when we want to scale the x-axis, I'm going to show you a different way because this will click for some of you maybe better, is that normally when let's start with scaling the y since that's what we've always done. So it's down 1, so right away you have to go down 1 and put a horizontal center. That's your wave center. You got to do that right away before you forget that you're shifting everything, and label it negative 1. Okay, so that's your new middle. That's the middle. Everything moves down 1. And then let's do the x-axis. Oh, the y-axis. What's the highest and lowest? What's the amplitude? The amplitude is 1. That's your default. So the highest point will be at 0, and the lowest point will be at negative 2. So everything happens in between there. Nothing goes higher or lower than 0 and negative 2. Great, x-axis. So on the x-axis, normally, let me explain it this way. Normally x would be from 0 to 2 pi for a period. Right? The real domain is, all reals, but just for one period, normally that's what would happen. Since we shift left pi, watch what I'll do is I'll just subtract pi from each of the endpoints. Since I'm shifting to the left pi, I'm going to subtract 1. So now our new period will go from negative pi to what? To pi, right. So when we scale our x-axis, we're going to go from negative pi to pi. So let's label pi. Let's put that somewhere over here. That's negative pi, and this is going to be pi. And the middle, we already know that's 0. It's already labeled, so that's going to be that place. And then we cut it in half and half. We know that's at pi over 2, but we won't label it. So we're ready to graph. So it's sine. So where do we start? At the middle or at the highest? Middle. middle, which is here, middle. And then do we go up or down? Since A is positive 1, we go up, so to the highest, which is right there, middle, low, lowest, middle. Middle, high, middle, low, middle, and make your arrows so that you know that it just keeps going, even though we graphed only one period. Okay, so these, hopefully this is the easy thing for you to do. Now, the best part, of course, is the applications. So let's look at a Ferris wheel example, and this is, so you don't have to copy down the example because it's already in the book. I'll try and zoom in here. So, example 3 here. Okay, so here we have our Ferris wheel, right? And you can almost visualize as you go around this that you're stretching out, you're graphing that way, kind of like the website, the Touch Trig website I showed you. So here's so you're riding this Ferris wheel, and it turns for 180 seconds. 180 seconds. Your height h in feet above the ground at any time t in seconds can be modeled by this equation, this trig equation right here. You can model lots of things with trig equations. So the height, so let's identify what's in this equation right here. What's the amplitude? You tell me. Amplitude is 85, right? So from the center of the wave, the highest it goes up is 85 and the lowest is 85. What's the, what's B? So the period then would be, what's the formula for the period? This you have to know. 2 pi over B, right? The frequency is pi over 20. So you would do 2 pi, it shows you right here, 2 pi over B, which is 40. And that will give you the period. The period is 40. Okay? So it will repeat every 40 seconds. Every 40 seconds we repeat. Let's look at the equation again. What does this minus 10 do? Shifts to the right 10. And what is plus 90? Up 90. So see how the middle of the wave is at 90? That's the middle. And then from there, the maximum and minimum height of the Ferris wheel, you would take this 90 and you would add 85 to get the highest point up here, and you would take the 90 and you would subtract 85 to get the lowest point for the height, which makes sense. That see the lowest point is 5 feet off the ground. That's where you, when you're sitting in the Ferris wheel and you're getting started, you're 5 feet above the ground. That makes sense, right? Roughly. If you got a negative height, that's going to be a dangerous Ferris wheel. Okay, so are there any questions about this? How to find the maximum and minimum? You know how to graph it already. And then you can answer at any point in time, you could know how high off the ground you are just by plugging in something in for t seconds. So for now, you're going to be given usually the model. It's given to you, but there's also a way to take a description and create the model, and that's where it gets more interesting, which we'll get there. By the end, that's really the ultimate goal, is to take a description and create the model and then use the model for anything, any function.